Hi, this video is about discussing the various methods of driving LED displays from a microcontroller, the pros and cons of each version, what driver chips you can use, etc. This obviously depends on your particular needs, so I think we'll go over the simple stuff first, like the 7-segment displays, then move on to the dot matrix displays. So there's a few methods you can use. You can use a driver chip, like the MAX7219, or direct drive LED display from the microcontroller pins. It depends on the digit you want, really. If you want an 8-digit display or a 4-digit display, you can use a driver chip like the MAX7219 modules, like these here. The cheapest chips, and they're dead easy to interface to a microcontroller. There's a library available, and the code is dead simple to write. If you get like these, as you can see here, for just short of £14, you can get 5 of them. So that's pretty much a bargain. They've got mounting holes here, and you can daisy chain them as well. So that's one option. The benefit of that one is easy to code, cheap, low component count, and you can chain up to 16 of them, I think. That's depending on the limit of the Arduino's memory. So in most cases, if you just wanted to make a clock, you could actually buy something based on the Holtec chip, which can drive them. Again, there's a library for that. Another option is the ICM7228, which I'll show you one of my projects, which is here. As you can see, there's no current limit resistors, the component count's very low. The reason why there's no current limit resistors is because the chip handles a constant current drive like the 7219. So there's absolutely no need for any external transistors, resistors, and all the multiplexing is done in the chip, and you just simply send it the data and it displays it. So that's the first method. I did talk about directly driving them. That's another method you could use in this example here, using common cathode displays. I've seen a lot of examples on the internet where they don't have current limiting resistors. They are absolutely essential, otherwise you'll damage your microcontroller. If you're going to use multiplexing like this, you need to use high efficiency displays that can display a decent brightness for only 2 to 5 milliamps. The reason being for that is when you're using multiplexing, you need to put, for example, a 4-digit display, you need to put 4 times the amount of current through the display as you would normally, because only one digit's on for any one time. Now, in doing that, you're going to get quite a lot of current. So in this example here, you're going to need 20 milliamps per segment. Now an Arduino can provide that amount of current, but it's right on the limit, and you've got to watch out the total limiter for the chip, otherwise you'll burn the bonding wires out inside the chip module, and it will destroy it. For the digits, you must use transistors, simply because when all digits are on at once, it could be pulling 80 milliamps, which is more than than Arduino can supply. Another disadvantage for this method is it uses a lot of microcontroller pins. So that's one example. I mean, a lot of them, like I say here, no current limiting resistors. Bad idea. Don't do that. It's when you're using a PIC microcontroller, it's the same thing, but that's using common anode displays. You can see how many pins it uses. It's either for maybe 2 or 3 digits. Again, I did use that method on one of my projects, which is this here. This little gadget. It provides roughly 5 milliamps of current per segment, and the display's are multiplexed, so it's switching between the two. After the current limiting resistors are set to put 10 milliamps through, it's only one of those digits on is only on for any one time. There's a little project here I made. Current limit resistors are hidden underneath this board, but you can see the displays and the anode transistors there, and the base driver transistors are 1.2K. That's okay, but like I say, it uses a lot of pins, so and it's quite messy to prototype as well. When you come into Pro on a breadboard, it's a lot of wires. It can be quite difficult. So the other method you could use is a chain of shift registers instead. So I'll just show you a schematic of one of the things I'm working on now. This thing is the circuit diagram for the clock shown in the intro of this video, and as you can see, there's a chain of shift registers. Disadvantage for this is quite a high component count. You needed current limiting resistors. Advantage is it doesn't use many pins on the microcontroller. And this method I haven't used multiplexing. I prefer not to do that because you've got more control over what you can put through the display. Writing the multiplexing code is quite complicated. So this method is typically no library, and you've got to write all the code yourself. So that's the disadvantage of that method. Current limiting resistors in this are 270 ohms because these large displays here have 3 LED chips per segment, so they need around 6.3 volts to light them. So I'm running it from a 12 volt supply. So a perfect size current limit resistors. On the decimal point, it's 510 ohms, which is only one LED chip for the decimal point. So that's why. The code for that, I'll just show you the code for that, which is decides to load. Now, as you can see here, there's no library for this, so you've got to set all the bit patterns here, your binary patterns for your shift registers. If we're using multiplexing, you have to write all the multiplexing code as well. So, and then basically, this is the bit that shifts out the digits. So you're grabbing the time and date from the RTC, separating it into individual digits, and then shifting out to the shift registers. So now your library do that, but in this case you have to do it yourself. And then finally, that's pretty much it for 7-segment displays. For dot matrix displays, the only method you can use with them is, again, I would just recommend buying a Max 7219 base display. It's the cheapest chips and you use a library. There's really no other option to that, unless you're trying to get a salvaged unit working like I did. This thing here is a LED module from a cinema lobby board, which I got during lockdown to mess about with. Basically, there's a chase and shift registers here and some transistors that select the rows. Again, I had to write all the multiplexing code, so the code of that was quite complicated. That's the rear of the module. Now, to save pins on the microcontroller, I just use a shift register to select the rows instead. So, but yeah, that basically sums it up. I'll put the pros and cons in text form as I go through the video. Put a little description at the end where you can read an article on a blog about it. But basically, to sum up, don't believe everything you find on the internet, because a lot of the examples they just won't work. Because you find many of the circuits have actually not actually built them; they're just done on a simulator. Like I say, the biggest thing is no current limit resistors for the LED segments when you're directly driving it from a microcontroller. That is absolutely important. So I think for now, we'll draw that to a close. And if you've got any questions, or you can check my blog, which I'll put at the end of the video, or you can put a comment down below. Anyway, thanks for watching.